All right, you guys ready?
Yes, sir.
I got faith in you. You guys got this.
Yes, sir.
You do. All right, you ready? Class.
Yeah. You only heard me, huh? I said it. I was just scratching my eye.
Okay. So now I know I don't need to remind anyone that the earbuds need to be off and away, right? Because during my class, I need you guys. You're paying attention to me, okay? Not whatever you're shaking off where you make sense, okay? So make sure those are off and away, okay? Yes, I get it, shake it off, but yeah. Anyway.
Why don't you tell Aiden? Tell him as loud as way.
Okay, good.
That's right.
So now on these notes right here, which is going to be on page 13 of my notebook, did we update? Where's yours? Why don't you have one? I just handed them out. Did you just sneak into my class right now? Where the hell you been? Did she just sneak in? Jerry. Anyway, so this is going to be on page 13 of my notebook. Did anyone actually go and update their table of contents like I ask them to all the time?
Wait, I never got table of contents. You just read it.
No, I'll get you one. I'll get you one. Don't worry. Don't listen to him. I'll get you one. Okay.
Oh yeah. Wait, don't you actually just write it?
Nope.
Wait, what?
Now, graphing using intercepts. If you are reading through here, this is stuff that you guys actually did do back in either geometry or algebra 3-4. But it depends on who your teacher was. Because I know some teachers don't do any teaching. They just sit around and put on movies all the time. Okay? They don't actually teach. Other teachers actually try, it's just some people don't pay attention.
Is that a picture, but it's a printed like a day?
Says all equations in the form of ax plus by equals c are straight lines when graphed, as long as a and b are not both zero, are called linear equations in two variables. This is also referred to as the standard form. So, does it say that up there?
Yes.
Where does it say standard form?
It says
It doesn't. So you might want to write it where it says that this is also known as the standard form. So that would be good. So you can actually see it as standard form. Locating intercept. To locate the x-intercept, you set y equal to 0 and solve for x. To locate the y-intercept, we set x equal to 0 and solve for y. So kind of like what we just did on our warm-up, we just did this one right here. Let's see if anyone actually remembered it from previously. But if not, that's why I wanted to go step by step on how to do these things. Using intercepts to graph a linear equation. All right, so this is what you're going to do. We're going to do this problem twice. So first time I'm going to do it, I'm going to go like this. I'm going to make a little table, x, y. I'm going to have a 0 here and a 0 here. So I'm going to do this problem twice. So you have to find both of these. Every time you do this like this, because we have to find both coordinates. Now I'm going to plug in. So let's go ahead and plug in 0 for my x. That's what that means. 3 parentheses 0 plus 2y equals 6. 0 is the magic number. I like 0. Anything times 0 is?
0.
So all of it goes away. So that whole thing goes away. So I'm just left with 2y equals 6. And to get y by itself, I need to undo my multiplication there. So I need to divide both sides by 2. Very good. Y is
A 3.
very good. 3. Now I'm going to do this again. But this time, instead of plugging in 0 for my x, I'm now going to plug in 0 for my y. Because I asked.
Why? Because you asked. I get it.
See? Kind of like why. You said why.
Yes.
Okay, but I'm telling you, that's why I'm doing it.
I'm just doing it. Just teach us. Just teach us. Mister, has anyone even gone to the bathroom yet?
Is the 10-minute mark yet?
Yes, it is.
Has it been the 10-minute mark?
Yes.
Where are you at? Where are you at? You're right here, 16. At 26, the first person should have been able to go.
It's been 20 minutes.
Okay, so that's you. Nico.
Of course, he's the first one. Tell him to go already.
That what I just did?
Yeah. But.
Thank you. All right, so let's go ahead and plug it in. 3x plus 2. I'm going to replace my y with 0 equals 6. I like color coordinating these. I do. I change colors to make it look amazing. So, 2 times 0 is?
0.
Good. So it's now going to be leaving 3x is equal to 6. And to get x by itself, I'm going to do what to both sides here?
Divide by 3.
Divide by 3. Very good. Divide both sides by 3. X is 6 divided by 3?
2.
So my solution is going to look like this. These are my coordinates. They are my coordinates. So when I graph those, I'm going to put those 2 points on my graph. Do I have a graph next page? There it is. So my points are, let me see, 0, 3, and 2, 0. 0, 3. Right there. And 2, 0. So I just plotted my 2 points there. And there is a rule in geometry. Between any 2 points, there's exactly 1 line. So in between those 2 points, I could just draw a line. So wait a minute. I actually have a meter stick for this.
God, that's a long stick.
It's a meter. There we go. Now, I was able to graph this using intercepts, using my 2 points and just drawing a line. So when you go through and do this on your homework, all you have to do is plot this point, and then you draw your line. Or I believe the tool that you guys have is you just click on the straight line, you touch this point, then you go down and over and then touch this point, and then your straight line will show up.
It gives us the coordinates?
No, you get the coordinates. How did we get the coordinates? This right here. Yeah, we got these coordinates here. And then when it says graph it, when you bring up the grapher, that's all you have to do. You select the straight line and then put 2 points on there. Does that make sense? Yeah? Or no?
Oh, yeah.
I could actually pull it up to show you if that's what you're questioning it.
Maybe.
Okay, I will. Hold on, let me see if I can pull it up.
Oh, mister, you saw metal straw?
You know, this guy's kind of random, just like throwing out anything he reads at any given time. So I will pull it up right now so we could see. This is actually going to be from the homework. Sorry, internet is not my friend today. All right, here is what it looks like on your homework. So this is what number 1 is on your homework. I get x plus y equals -3. So on your homework page, which would be what page? Okay. And this is question 1. You're writing this down. X plus y equals -3. And just so you know, yours might be different numbers. You could write it down in your list if you want, but it might be different numbers when it comes to your homework. Everyone's homework should be slightly different. So you can't just copy off the person next to you.
Right.
Okay? So I will show you on this one. So I'm going to start off by showing what I'm doing. X, Y, 0, 0. Because that's how I started my previous problem, right?
Yeah.
I'm going to go in, I'm going to plug in numbers and show my work. So I'm going to plug in 0 plus y equals negative 3. So in this case, y equals negative 3. The other one is going to be x plus 0 equals negative 3. Right? And so that means that x equals negative 3. And there's my 2 points. I don't know if you could, there we go. So there's my 2 points that I have, and I'm going to use those. So 0, negative 3, negative 3, 0. So let's bring up that homework again. I'm going to select a straight line, which is right here. So there's my line tool. 0, negative 3. I'm going to use the mouse because 0, negative 3. 0, negative 3 right here. And the other one was? Negative 3, 0. So if you notice, my line pops up. And I didn't select it. I did not select it yet. So because I know you're paying attention. You're not staring at your phone because you wouldn't do something like that. Would you? Because this is your question. So that would be kind of rude. You wouldn't do that, would you? No. Okay. I didn't select it yet just so you could see when you're selecting it, you could actually just put it, like hover right there, put your mouse over it, and it'll give you what the coordinate is. So instead of accidentally selecting the wrong thing by just pushing your finger on there, you could actually hover over it and see what it would come out to be, right? So I'm going to go right here. There's my line. Save it. Check answer. Does that make sense?
Yes, sir.
Did I lose you on that one?
Yeah.
Okay, what part where did I lose you at?
So, and you can click any, no matter what. You say you don't have to do something.
Okay, what I did.
Oh, no, that doesn't. No, damn. Yeah.
Here, I'm going to pop it out again. What I did is, I just moused over it. So I just used my little cursor. I put over it, and before you select it, on the top, it'll tell you where your mouse is at. It'll give you the coordinate where your mouse is located at. Does that make sense?
Yeah.
Okay. And so then, when it's there, then you click it. And then after you go to your second one, I verified it on top, and then there's my point. Okay?
Yeah.
All right. There we go. All right, hopefully that's helpful. All right, let's go. All right, next one is slope. Slope of the line through distinct points. X1, Y1, X2, Y2. It's a change in Y over the change in X, which is rise over run. Also, you're going to have to see this one because it's going to be delta Y divided by delta X. You will still see this definition if you go into the book, or you says, help me solve this, or you go into one of those other teaching tools that helps you finish this. So it still comes up as delta Y over delta X. All right, so as we're going through here, delta Y, delta X, where X2 minus X1 cannot equal 0. Why can the bottom right here, why can this not equal 0? Anyone?
Because it's only dummy equals 1. Zero.
Why can it not? That's what this means. Why can this not equal 0?
Because it has to move
No. Any fraction. Any fraction. Why can the bottom number why can it not equal 0? Yeah.
Because that wouldn't make it a fraction.
No. Can you divide by 0?
No.
No. In a fraction, that would be over 0, right? That's divided by 0. Because if you divide by 0, that is undefined. That's something that you're going to see, especially when you graph this. Your calculator is going to spit out an answer that says undefined. So whenever you get something like that and it's undefined, you know what happened. You ended up with 0 in the denominator. Find the slope of the line passing through the pair of points. Now, we're going to go through. I'm going to label it, and we're going to put these in. So this is actually going to be my x1, y1, x2, y2. Now, use the formula that was on the previous slide, plug that in, and try and work this real quick. Because the slope formula is stuff that I know you have done before. Even if you had Mr. Hagen last year. I know you had to do it. I know. I'm telling you, stay off the devil's lettuce.
Actually, no joke. Listen, do you do
No joke. Yeah, devil's lettuce is bad for you, right?
Listen, do you do that?
I know.
Yeah, someone else is on it.
Okay, try it. We're using this formula right here. Use that formula there. What's your y2?
Y2, -3.
No. Y2. Look at it. I labeled your x's and y's for you. Which one is y2? Okay. I kind of put it right here. Where's y2? That one's y2. Yeah. So you're gonna plug into this formula here. Okay. So pick those out. No.
Is it possible to go from 1 to 18?
Go from 1 to 18.
Yeah, it's like copy.
Oh, all the pages? Oh. Yeah, we have all the pages. If you need help actually filling in your notebook, you just have to go get a notebook for this class.
Oh.
Can we talk about that the other day? Yeah, you zoned out a little bit. It's alright. So, seriously, math class is boring. Okay, even I fall asleep while I'm teaching this.
That's so quiet. I was just like, wait, that can't happen, right?
Okay, so watch this. So 4 minus -1. So it should be minus negative. Okay? Minus -1 because that one's a negative. Okay? And then the other one should be here, -2, minus -3. Because your formula has a minus sign, so you kind of let that out. Yeah, minus. So, I'm going to help you guys fill this in. 4 minus sign, right? 4 minus, okay, y1, which is right here, -1, over x2, which is minus x1, which is
-3.
there you go. So we're plugging in our numbers as we go. And I plugged in using parentheses because a negative and a minus sign together gets super confusing. I don't want you guys to get confused like that. So minus a negative. Now, serious question. Even if my name was Nicholas and I had earbuds in and not paying attention to what was going on in class, a negative times a negative is a... Don't, come on. I don't say I don't know. A negative times a negative is a... I mean, put the earbuds in. It means take them out. You just put the second one in. How dare you? Okay, help him out. Why's your homie here? Don't let him fail. A negative times a negative is positive. So that means if I line it up and I have two negatives next to each other in front of parentheses like this, those become positive. Those also become positive. A negative times a negative
Makes a positive.
is a positive. Now,
Yeah,
serious
but
question.
There, on the top, there was no negative for the 4. You said negative and a negative.
This 4. See this?
There's no negative.
Okay, now watch this. Okay, I'm going to do it again. I'm going to change colors so you can see it. 4 minus, because my formula has a minus here, right?
Oh.
The formula has a minus. That's where I'm getting that other one.
Okay.
So the formula has a minus, and I'm going to put in parentheses. What was y from my first point?
1.
No, not 1.
Negative 1.
Negative 1. That's why I'm putting it in parentheses like that. I'm putting in parentheses because the y from my other point is a negative 1. So that means I could look at it and say, hey, the y is positive 4, and the y is negative 1. A little bit better? Okay, and now from the formula, there's still that minus sign from the formula, right? And that's where I get the negative and the negative. So 2 negatives together will always make a positive. Does that make sense? Kind of? Okay. All right, that's where we get there. And then,
But for the bottom, there's 3 minus symbol.
oh, you're right.
So what does it make?
Okay, so now, but there's only 2 next to each other.
So what does that make the negative 2?
Okay, that's still a negative 2.
So it doesn't change it.
It's not going to change it because it's not next to the other one. It would only do it if they're next to each other like this. Just like here and here. But this one is out here. Okay, that one's separated from these other 2. So that means because the negative and negative together, a minus and negative, change that to positive. So now it says, now think about your numbers. Negative 2 plus 3. It's going to be positive 1, isn't it? Now, I'm going to go way back. You'll see. You'll see. I'm going to do a number line here. Negative 2, right? So anything positive goes which way? Goes that way, right? If this is a number line, so negative 1, 0, 1, 2, 3, right? Anything positive moves to the right. So if I'm adding numbers, that's going to go to the right, isn't it? Say yes. That's adding numbers, and so that means that a negative goes left. If I subtract, I'm going to go left, right? So if I take 3 minus 1, it would go that way, wouldn't it?
3 minus 1,
Yeah, it would go that way. So that, we've proven this now, right? So now what this is saying is, I'm going to start at negative 2. I'm going to start right here. Okay? And from here, it says that I'm going to subtract, right? Because my number was actually negative 2 minus negative 3. Before I changed anything, right? Okay. So I'm subtracting, so I go that way, right? So I go that way, how many spaces?
2.
It says I'm going this way 3 spaces. But the problem is it's negative though, right? So if it's negative, what negative actually means, it's the opposite of that number. So the opposite of negative 3 is positive 3. And that's where that comes into play. So instead of going that way, it is now going to go, because it's the opposite of the opposite, it goes this way, 3. So that means that's why it turns into a plus, because the opposite of an opposite becomes a positive. Maybe? Kinda?
Yeah, but the negative 2 though.
Oh, it's just where we're starting at. So you would only deal with it if you have 2 next to each other like these. But that means it's just, I'm starting at negative 2 on my number line, which is right there. It's just always going to be my starting point. If I had a different, like see this one right here for the y value? That said I was starting at positive 4. I was starting at positive 4. It didn't matter where it's at. That means it is 4 on the number line. This one over here says I started at negative 2 on the number line. Más o menos?
So it doesn't matter because it's
Yeah, that's just my starting point, and then from there I'm going to go left or right, however much. All right, so let's go ahead and finish this up. So that positive 4, and a positive 1 is going to give me a positive 5. So 4 plus 1 is 5, right? And on the bottom it's negative 2 plus 3, which is going to give me a positive 1. There we go. So now the slope, so this is my slope formula, which also refers to as M.
Bless you.
Oh!
Bless you.
Oh! Thank you very much.
Look, he sees as much as my best friend. He sees it like 7 times in one sitting.
Man, you know, it's I'm allergic to bull crap, and so a lot of people, you know, it just gets deep in here sometimes, and so therefore, yeah, it's like my allergies start acting up because of it. Anyway, all right. So my slope is going to be 5, but if I were to write this as rise over run, my rise, so that means it goes up 5 and right 1. Yes, no, maybe, hopefully, possibly, on occasion. No, yes, good, thank you. I just need some thumbs up there. I appreciate it. Okay, good job. Now, for the people that fell asleep already, waiting for me that last time, okay, we're going to have some issues here in a second. So, slope-intercept form means that it is going to be my y equals mx plus b. Y equals mx plus b. Y equals what?
That's why you want to search there?
Come on, y equals what? mx plus b. It's the formula. M refers to my slope. B is my y-intercept. Y-intercept is going to be 2 in this problem on this one. The y-intercept on this one right here, there's a minus sign out there, right? It says minus 4. The sign goes with the number, always. The sign goes with the number. So since this says minus 4, it makes it a negative 4. Plus 2, it makes it a positive 2.
Bless you. Bless you.
Oh, man! Ah! Big time. Big time. Okay, it's getting deep in here. It's getting deep. All right, questions, concerns, complaints, conspiracy theories.
No.
Got a conspiracy theory that Aiden's asleep again? Wake up, homie. Come on now. Come on.
Wake up, perro.
All right, before I continue this part right here, this is what I'm going to have you guys do. I'm going to pause the video. I want you guys to open up your MyLab, and we're going to start doing the first couple problems, which have to do getting the slope and finding the graph. Okay? Go ahead, pull that out right about when. All right, we're continuing the video for this one. Slope-intercept form of the equation of a line graphing y equals mx plus b using slope and intercept. Okay, we start by plot the point containing the y-intercept on the y-axis. This point is 0, comma b. So whatever my b value is, and my earbuds are away, I'm going to put it right there on the y-axis. Obtaining a second point using the slope m, write m as a fraction, rise over run, starting with the point containing the y-intercept to plot this point. Use straight edge to draw a line through the 2 points. Draw arrowheads at the end of each 2 lines. Show that the line continues indefinitely in both directions. Graph the line using slope and intercept, y-intercept. So y equals 2/3 x plus 2. I'm going to write this down. M. My slope. Can someone tell me what the slope was on that previous slide?
Y equals mx plus b.
Okay, mx plus b. So now, look at the m. Look at the equation that was given. The m is the number in front of the x, right? Yes, it is. Don't shake your head at me. It is. So the previous slide, okay, what's the number in front of the x? This one here? Are you on this one here, or are you on a different one? Okay, there. Yeah, get to this one, slide 9. So if you're looking at the bottom right here, slide 9. Does that make sense?
Yeah.
Okay, so the number in front of the x. The number in front of the x is this thing right here, right? So my slope, my m, is going to be 2/3. So that is a 2 that goes up and a 3 to the right. Now my b is the y-intercept. So from the previous problem, what was my b value? Go look at the equation on the previous problem right there. What was the b? 2. Where did we get 2? There you go. This is my b. Y equals mx plus b. So my b is that number right there. My m is the number right in front of the x. So my b is 2. My b is 2. Now, as a coordinate, the b is going to be 0, comma b, which is 0, comma 2. This is my y-intercept. Now, starting at my y-intercept, which is 0, 2, 0, 2, I'm going to put that right here. And my slope, m, is 2/3. So that means that's going to go 2 which way? Up and to the right.
3.
Let's count it. 1, 2. There's 2 up and to the right. 1, 2, 3. There's my point. So now, in between my 2 points, I do what? Una línea. See? Draw a line. All right, I'm going to get it this time. I know I am. There we go. Look at that. Beauty, eh?
How do we know 2 for the y-axis?
For which one?
How do we know 2 for the y-axis?
This one right here?
Yeah.
B. This is my B. That's the 2. I take that number, and that is called my y-intercept. That's where it's going to cross the y-axis. It crosses the y-axis right here at 2, and it's always, my coordinate is 0, comma b. We got that information from right here. It's always 0, comma b. Whatever my b value is, whatever number that is, that's where it's going to end up at. There we go. That make a little bit more sense, or is that a little bit of nonsense?
I mean, I'll say no.
Okay, hey, we're going to do a bunch of these. So if by the end, you're going to have this, because you're going to do it so many times that you cannot forget it, no matter how much weed you smoke. You got this. I got faith in you, man. You got this. All right, we okay here now? So, graph the linear function 2x plus 5y equals 0 by using the slope and the y-intercept. Now, these ones, you can get away with just using my 0, 0 for my x and y-intercept, but it's asking for slope and y-intercept. That's important. It's asking for that. So because it's asking for that, that means that when you go and put your points on the graph, it's going to be wrong if you put the points on the x and y axis. It's going to be wrong if you only use those. Okay? You have to change this. We have to do a little bit of algebra. We're going to do some algebra. So I need to turn that equation, slide 11, if you've got lost, slide number 11. Each slide actually has a little number on the bottom right-hand corner, if you're looking. we're going to do algebra here. So I'm going to turn that into y equals mx plus b. That means my y needs to get by itself. I'm going to isolate my y value. Awesome. What'd you do? Oh, okay. All right. So we're going to turn it into y equals mx plus b. That means I'm going to get the y by itself. So the first thing I do is get rid of my 2x. My 2x is being added to my 5y. So the opposite of that addition there is subtraction. So to undo that, I need to now subtract. I need to subtract 2x from both sides of my equal sign. Because golden rule in math says do unto one side as you do unto the other. So I'm going to take away 2x from here. So what's going to happen? 2x minus 2x. 0. That is the golden number. That is the magic number. It goes away. So now that that's gone, I'm left with 5y equals 0 minus 2x, which is just negative 2x. Is my y by itself yet? Say no. No. What's happening to my y? What is that 5 doing to the y? It's multiplying, right? It's just right there next to it. There is no operator there, so it's implied that that is multiplication. So 5y means 5 is multiplying times the y. Now, to undo a multiplication, I need the opposite of that. What's the opposite of multiplication? Division. So that means I'm going to divide both sides by 5. There we go. So now those cancel. I'm left with y equals negative 2 over 5 x. Now, what is my b value here? This is a good one here. What is my b value? Perfect. It is 0. Why is it 0? There's nothing here, right? If there's nothing here, that implies that that is 0. So my b value there is 0. Because it's not there, right? So I could write it, just to make you guys happy. Plus, I hate it when it does that. You do a plus 0, that one still works, right? So now you can see that it says plus 0, but nothing was there. All right, so now it says graph the function using slope and intercept. So my y-intercept, let's go back to my graph, which is next slide. I forgot to put a thingy in there. So now I have to draw one, but yours is going to be so much better than mine, because my drawing sucks. My things I have to identify, my slope, m, and my y-intercept, which is also my b. From the problem that I just did, on the previous page, what is my slope? What was the slope?
0.
Negative 2 over 5. Negative 2 over 5. Slope is the number in front of my x. Right here, my slope is right here. Negative 2 over 5. This is my b. So, I go over here, slope is negative 2 over 5, and my b value is 0. So the intercept point is going to be 0, 0. Because b is the 0 there, right? You zone out on me? Not too much. Oh, okay. It's getting tired. End of the day. All right, let's see. So if you guys remember the rise over run, like I said, rise over run. So if it's a negative rise, what do you think it's going to go?
Right. I mean, left.
On that last problem, right here, rise, it's positive, isn't it? It was positive, wasn't it?
Yeah.
So therefore, it went up, and then it goes right 3.
Oh, since it's negative, it's going to go down.
There we go. It's going to go down. Down how much? 2, and it's going to go right. Always to the right, because we always read math from left to right. So in my equations, it's always going from left to right.
So never go down.
It could, but you would have to reverse the whole thing. There's no point in doing it. Yeah, always right. So if you want to be fancy, you could reverse both of them. You could say, hey, how about instead, if I want to reverse the whole thing, instead of going down and right, what else would I have done? Could you go up and left? That's what you could do. But you don't have to. But that's trying to be too fancy. But we ain't trying to make it fancy here, are we?
No.
But you do understand that if it is going to be the opposite, you can go the other direction by switching it. Does that make sense?
Yeah.
So as a consistency, I always do my math problems from left to right. Because we read here in America from left to right, unless you're reading manga, which is from right to left. Don't do that, okay? I'm more of a manhwa type person where you just keep scrolling down. Okay. Anyway, so start at my intercept, which is Aki 0, 0, right? And from that point right there, Matthew, you zoned out again. Okay, from that point right there, I'm going to go what? Down, down 2, and so 1, 2, and to the right. 1, 2, 3, 4, 5. Now, you ready to try to be fancy on this one? Let's see if we can go fancy. So instead of doing down and to the right, what else did we say we could do? Up to the left. So up how much? 2, 1, 2, and to the left, how many? 1, 2, 3, 4, 5. So if my graph was perfect, this would work out, but my graph sucks. And I will do my best to make it fit. So let's see if it all fits here. Just like that. So even if you tried to make it go fancy by going up and to the left, even though that it was a negative, it works out going positive down and to the right because it's negative. So you could do either way, but I recommend always reading your math problems from left to right. So it's always either up or down, but moving to the right. Does that make sense? Better? Okay. Aiden, you good? All right. Anyone? Questions, concerns, conspiracy theories? No conspiracy theories here? Okay, good. Are we checking our phone for some reason? Okay, we wouldn't be doing that, right? Not implying that it was you that just took a nap right now and pulled up his phone and, started looking up conspiracy theories. It was that one. Yes. Yeah, okay. Where are we at now? This thing right here. Which one's that? Okay, there we go. So then it's here and here. Like I said, there's so many that it's hard for me to keep track of. That's why I have you guys. This thing. You notice it's like really quiet in here right now? All right, let's keep going. Graphing a horizontal line if y equals -4. Okay, y equals -4. So what does y equal? So right here, what is this first y going to equal? What's my second y going to equal? Y equals what?
-4.
What's my third Y going to equal?
-4.
Does it matter what my X is?
No.
Do you know why? Okay. Just like my real X, out of the picture. Not even there. See what I did there? Yeah. The ex-wife joke. Okay. Anyway, there is no X's. There is no X's. So guess what? The X's don't matter. So can I put anything there? Can I put 0 there?
Yeah.
Because the Y is always going to be what?
4. -4.
Good. What if I put -3? What's my Y going to be? Because it says the Y is always...
-4.
Okay, what if I put +2? Does that matter? No. Because my Y is always... Okay, let's go ahead. On my graph, my Y value is always -4. Here's my Y. So right here, this is -4. So does it matter what the X is? No. So if I go over to 2, my Y value is -4. If I go over here to -3, what is my Y value?
-4.
If I go out to -6, what's my Y value? So, in those type of situations, does that make sense? Y value is always -4. So this is called a horizontal line. It's almost like the top of the slide. Horizontal line. It's weird. Looking up and seeing people scrolling through their feed for some reason instead of actually writing down my notes. But you ain't heard it from me because I'm one to gossip. Thank you for those people that are still following along. I'm sorry. I am not very interesting. And it's super weird and quiet now, right? It's weird. It's like there's nothing, no dancing monkey in class that everyone has to pay attention to. Okay. There you go. Here's another one. It says X is what?
2.
So X is?
2.
Okay. So what about my second one? X is?
2.
Third one?
2. Why does it matter?
Why does it matter, right? Why does it matter? Why? That's why it's my X. It was a 2. Not a 10. A 2. See what I did there?
Yeah.
Yeah, see what I did? Okay. All right, good. Okay, so now, Y. Okay, it doesn't matter. 0, -1, or we could even go very negative, just like my X. All right, let's go ahead and graph those. So X is always,
2.
so X is 2. So does it matter? So I can go, so no matter what the Y is, the X value is always 2. There you go. Now, this one right here is special because when we do this mathematically, rise look at these 2 points right here. This one here and this one here. Going from this one to this one, what's my rise?
2.
It goes up 2, right? So it goes up 2. Does it go over?
No.
It doesn't go over at all, does it? It doesn't move to the right at all, does it? So what do I put for my run? How much is it running?
0.
It goes up 2, but my run is 0. What type of number is this? I used it as a special word earlier.
Whole number.
Undefined. Why is it undefined? 0 on the bottom. It is undefined. It is divide by 0 is undefined. So this one is undefined. So whenever you do and you find that a slope is undefined, that means your line's straight up and down. Whenever it's undefined, your line is up and down. Let's back that thing up right here. I'm going to use this point here and this point right here. Rise over run. Going from this point here to this point here, what's the rise? 0. It's going up 0, isn't it? It's going up 0, and my run to the right is going to be 1, 2, 3, 4, 5. It's going to be 5 there, right? 0 divided by 5. Think of it like this. You have 0 pizzas. You're going to divide it by 5 people. Do you all get the same amount of pizza?
There is no pizza to begin with.
There is no pizza, and so is it equal?
No. Yes.
It is equal, because you all get 0. Okay? Very good. Socialism right there. Okay? There is 0 pizza. It is divided equally among everyone. Everyone equally gets 0 pizza. Okay, socialism at work. So this one, my slope is 0. So when it is a horizontal line like this, my slope is 0. So if I'm plugging in and I find this, a slope of 0, I know the line's going to be this way. Now, hopefully that makes sense, because you do have homework that looks just like this. Just like this. Horizontal, vertical. I already talked about that. Baby. Hey, what?
Oh, no, we're good.
Okay, you good? Okay. There we go. Slope can be interpreted as a rate of change in applied situation. Now, any of you drive? Some people here drive, right? Do you drive? Yes? Oh, okay. You don't have to be shy about it. You know, you're big pimpin'. Everyone else got heel toe express. Okay? So this guy right here, he, 84 Honda Civic with the bumper taped on with duct tape. Okay?
No, I don't.
I'm telling you, he's got that classic Honda Civic with duct tape bumpers. Okay? Now, he was driving 45 miles an hour through the school zone over here. 45 miles per hour. That is a rate of change.
That's illegal.
That's a rate of change. It's 45 miles per hour. For every hour he drives, he goes how far? 45. So that's actually a slope, and it's also a rate of change. So 45 up for every 1 hour over. So that's what that is. A rate of change is also the slope. 2016, college freshmen were more politically polarized than they had been in the last 36 years. Line graph, next slide, show the percentage of college freshmen who were liberated or liberal or conservative. 1980, 2016, find the slope of the line segment representing liberal college freshmen. Round 1 decimal place, describe what the slope represents. Right here. Here's the 2 things. Slope, rise over run. Let's look at the blue one. Okay, rise, run. It goes from that point right there, which is 21. So it goes from 21 to 36. How much did it go up? 15? Okay. So it's saying that's up 15 over. So it goes from here, starts at 1980, and goes to, what's this, 2016 there?
2015.
2016. How many years is that? Watch this, watch. How far is it from 80 to 2000?
21.
How far from 36? Because we're going to 2016 here. And 16 goes here, so together, 36. So, this is an increase of 15 over 36, or I reduce the fraction and get 5 over 12. That makes sense? Nonsense?
512.
It reduces the fraction. If you divide this one by 3, you get 5. Divide this one by 3, you get 12.
Why are we dividing it by 2?
Isn't 15 3 times 5? Okay. Isn't 36 3 times 12? So what this is doing is reducing my fraction by a factor of 3. That's what that did. Okay? It just reduced the fraction. What I think that was the only one we had to look at. Yeah, we didn't have to do the other side. Yep, we didn't have to do the other side. We only had to do the blue line. Now, that being said, we already started working on the homework, so I know everyone should have at least one problem done from their homework. Yes? Matthew? Good. Now, how much time do we got left? We got like 10 minutes left, right? Yes, 10 minutes left. I expect you to pull out the homework.